Okay, everyone. In part one of this video, we talked about the basics of chapter 8, which was rate of return analysis to compare multiple alternatives. So I would like to use this piece of your textbook, which provides just a procedure to generalize this incremental rate of analysis approach. So it means that if I have multiple alternatives, one, two, three, or more, how can I compare them using rate of return analysis and choose the best alternative? So this procedure starts with step one. Step one says order the alternatives from a smaller to larger initial investment. So be careful. You have to sort them from a smallest to the largest initial investment. Then you need to compute the cash flow for each alternative. Assume or create equal lives. If they don't have equal lives, you can create. We have learned about that we can create or repeat the projects following the LCM approach. If the alternatives are revenue costs, do the following. Compute the I star value for all alternatives in the considered set. If your ISR is less than MARR, minimum attractive rate of return, drop that alternative. The candidate set or the feasible set will be those alternatives that you have their internal rate of return greater than MAR. The first alternative is called Defender. The second one, which is the more expensive one, is called Challenger. Compute the incremental cash flow, then you need to calculate the I star for Challenger minus Defender. If rate of return for Challenger minus Defender is greater than MAR, you will drop the Defender. Otherwise, you will drop the Challenger. So the winner of a given round moves to the next round and becomes the current Defender and is compared to the next Challenger. And you will repeat these steps from step 5 moving forward until you are done determining the best alternative that you have. Obviously, it will not be more meaningful unless we solve examples. To practice this procedure, I would like to start solving some problems from your textbook. The first example that I want to solve is problem 822 from your textbook that I want to implement this procedure or incremental rate of return analysis to compare two alternatives. So let's just look at problem 22. I want you to read this example. Let me just copy and paste it over here. So I want you to read this example first. So as you can see, you have two alternatives. One is variable speed and the other one is dual speed. You want to compare them using rate of return and determine which one should be selected. Let's say if MAR is 15%, minimum attractive rate of return is 15%. So I want to implement this procedure. What was step one? To sort them in an increasing order of initial investment. So I have to sort them in an increasing order. Just the initial investment. Initial investment is first cost. And if I want to order them, look at here, from smallest to largest. So it means that I should go with the order, sort them. When I sort them, it will be DS and then it will be VS. Okay. Then the next step is a step to compute the cash flow for each alternative, assume or create equal lives. So it seems that these two alternatives that we have just in this example, we have equal lifetimes, so I don't need to be worried about that. Step 3, it says if the alternatives are revenue cost, do this. You need to calculate the I star for all alternatives and compare that with MAR. So if you look at over here, we see that in this example, we have obviously revenue cost. So for doing the incremental analysis, if you recall, you need to calculate the incremental cash flow. You need to determine challenger minus defender. What was the challenger? Challenger is the more expensive one. Defender is the cheapest one. So right now I only have two alternatives for DS and VS. So when I want to solve this, I will go and calculate, probably, let me just change the color. No, yeah. I would say VS minus DS. The project with higher initial investments minus the cheapest one. So minus 250 minus 225. It will be negative 25. Negative 231 minus, let me just write it, negative 231 minus 235 will be 4. And if when you don't have any overhaul cost, it means it's 0. 0 minus 26K, it will be 26. And it will be negative 39 here. And in here, it will be 50 minus 10, which will be 40. Okay. Okay, so you need to calculate the I star for challenger minus defender. And if that rate is greater than MAR, you will drop the defender. Otherwise, you will drop the challenger. So let's just see. I just want to draw the cash flow diagram for the incremental comparison. So it will be at time 0. It seems I have 25. This AUC is annual operation cost, and for 6 years, I will have 4. I'll have 4. And for overhaul at year 3, I will have a 26. And I will have another overhaul in year 4, which will be 39 negative. And salvage value gap or incremental analysis will be 40 here. This is the incremental project for doing the comparison between these two alternatives. So I need to calculate the I star of this incremental analysis and see what is this value. Then I will compare it with MAR and I will proceed. So let's just go back to chapter 7. In chapter 7, how did we calculate the present, how did we calculate the rate of return? So for example, I can calculate present worth as a function of I and set it equal to 0. Let's just do the calculation. Present worth for this incremental analysis is at time 0, I already have a 25. I have these 4 annual operation costs in positive direction, which I will need to transform it to P. So I will need to shift it to time 0 P for that given a I% and 6. I have that $39 here at time 4, which is a single cash flow in future, shifted back to time 0, 5% and 4. And I have a $40 down there, which will be a single cash flow shifted back times 0, set it equal to 0. So the problem has created a hint for us, and it says, hey, I will be something between 16 to 18%. So if you recall from previous chapter, when we have a hint, you have to calculate for on present worth when I is equal to 16%. Once calculate present worth when I is equal to 18%, find the present worth and just do the interpolation and come up with the answers. So if I, in these equations, if I plug in I equal to 16%, once plugging I equal to 18%, and finally, if you do the interpolation, you will see that the value of I after interpolation, I star for V variable speed minus ds will be 17.4%, which is greater than minimum attractive rate of return in this example, which is 15%. So the algorithm tells you if the challenger minus defender, expensive minus cheaper one, has rate of return greater than MAR, you will drop the defender. So what does this mean? It means that over here, I would drop the defender, which is the cheapest project, and cheapest one over here is DS. So I will drop the cheaper or DS. Therefore, our conclusion is that higher investment, or I would say higher investments or VS is the winner. Higher investment will be the winner. That's the implementation of this algorithm for problem 822. I will let you take notes. Okay. The next example that we can solve to practice again this concept one more time is problem 8.32 from this chapter. I want you to read this example first. And actually what I recommend you to do is after you read this example, pause this video and try to solve this example yourself first. So pause this video, don't look at the solution unless you're done with this problem. Okay, so the problem says Old Southway company has determined that any of 4 machines can be used for their operation. The costs are given and all machines have 5 years of life. Minimum attractive rate of return MAR is 25%. And I want to know, using rate of return analysis, which alternative should be selected. Okay, so we want to follow that process. First, I have to sort these alternatives in an increasing order of only initial investment. So over here, it seems for projects, I only have cost, so it's not revenue cost, it's only cost. I have to also sort them in an increasing order of their first cost. So if I look at here, it will be alternative 1, 3, 4, 2. Okay. So the first thing that I have to do is doing a pairwise comparison. So I have to compare 3 versus 1. Let's create the incremental cash flow. So as 3 minus 1 is negative 32 minus 28, which means it will be, let me just write for the very first one. For first cost, for 3 minus 1 will be negative 32 minus 28, which will be negative 4. And that's why I have 4 negative in this direction. Then for annual operation costs, I have, again, 3 minus 1 will be negative 19 minus 20 will be 1. So it will be 1, 2, all the way to year 5 will be 1. So for this incremental cash flow, we need to determine I star, or internal rate of return. So probably I would just calculate present worth. If you don't like present worth, you can calculate annual worth analysis as well. It really doesn't matter for these examples like this. So it will be negative 4. It's a chapter 7 material again. 1, I have to convert it to P for this given A, I percent, and 3, I will set it equal to 0. So it seems that P given A, I percent, and 5 will be equal to 4. If you go to the tables and look at P given A, N equal to 5, and see where you can get close to something like 4, you will see that by looking at the tables, probably I can also show you the tables that we have. I just want to show you the value of the factors. So we said P given A when N is equal to 5. Look at P given A, N equal 5. For example, when I is 0.5%, the value is 4.9. Okay, so I want that number to be close to something like 4. Look at P given A column here. When N is equal to 5, it seems that number is still, 4.5. I want that number to be close to 4. So again, it means I have to move. For example, look at P given A, N equal to 5. That answer is getting closer to 4. It's 4.1 here. I equal 8%, P given A column, N5 is 3.99. So there is no doubt that P given A equal to 4 should have an interest rate between 7 and 8. I don't need to do exact calculation. Why? Because if I star is something between 7 and 8%, in this procedure, all I want is to compare this with MAR. And over here in this example, MAR was 25%, which is less than your MAR, or minimum attractive rate of return, which is 25%. So based on this algorithm, if it is less than 25%, less than MAR, you would drop the Challenger. So Challenger was the expensive project. So you will drop alternative 3. So therefore, I would say Defender or alternative 1 wins in this round. So I'll go back to my list and I will eliminate 3. The next comparison that I have to do is 4 versus 1. 4 versus 1. It's like a tournament that you have to complete. 4 minus 1. Look at here. Negative 33 minus 28 will be 5. And negative 18 minus 20 will be 2. So I will have an incremental cash flow looking like this. 5 here. From 1 to 5, I'll have $2 here. Again, I will need to calculate present worth as a function of I, which will be, again, if you don't like present worth, you can calculate the annual worth. Plus 2 times P given A, I% and 5, set it equal to 0. Okay. So I will set it equal to 0. Then I need to find the value of the factor, which will be I% and 5, which will be 2.5. I will follow a similar approach that I did for the previous one, walk over different tables and see for which value P given A when n is equal to 5 is closer to 2.5. Again, I don't need to do exact calculation because when I go over different tables, I can see that the value of I star is something between 20 and 30%. So if I want to show that again to you, for example, look at P given A column when n is equal to 5, for example, it's 399. I want this number to be close to 2.5. So for example, when I is equal to 18%, N5, P given A is 3.1272. So it seems that I'm moving toward the correct direction. For example, when I is equal to 35%, P given A, N equal to 5 is 2.22. So I was looking for 2.5. So let's just go to I equal to 25%. P given A, N equal to 5 is 2.68. And when I equal to 30%, P given A, N equal to 5 is 2.43. So the value of 2.5 is between these two tables. I equal to 25%, I equal to 30%. So as you can see, my I star, no matter what, is greater than MAR, which is 25%. So do you agree that when your MAR was, when your incremental analysis was greater than MAR, you would drop the defender. So therefore 4 wins. Therefore alternative 4 wins in this round. So alternative 4 wins. So I will go back to this list. I will drop 1. The next comparison is 2 versus 4. So it will be 2 versus 4. Again, you need to create the incremental cash flow. 2 minus 4, look at here. 2 negative 51 minus 33, negative 13 minus 18. So I will have 18 in negative at time 0. And for remaining 5 years, I have a positive cash flow, and that is $6,000. I need to again calculate the present worth as a function of I, set it equal to 0 because I want to find I star or rate of return for this. In chapter 7, we learned that present worth as a function of I is negative 18 plus 6 times P given A, I% and 3. I will set it equal to 0. So P given A, I% and 3 is equal to 3. Again, you walk over different tables, you will see that I star is between 18 and 20%. You do not need to calculate the exact values for examples like this because you just need to compare it with your minimum attractive rate of return, which is 25%. Which is obviously less than 25%. So following the procedure that we have, we will say that alternative 4 wins, which is the cheaper project. So I'll go back to this list. I will eliminate 2. And we conclude that I conclude alternative 4 is the champion, or is the first alternative. Okay. So that is the way to implement incremental rate of return analysis. But just something that you might ask is that, okay, what if I want to select two best alternatives? What should I do? The first thing that you might comes to your mind, okay, so automatically the next best alternative will be alternative two. No, that is not correct. If you want to determine two best alternatives, you have to go back to your list and redo your analysis from the scratch. We sorted the alternatives and we had this order. Look at here. We sorted them. We said 1, 3, 4, 2. Right now, I know 4 is the best alternative that have been selected. So I can, yes, eliminate 4 from this list. All I have to do is, again, redo everything for these projects, for alternatives 1, 3, 2. So again, I have to run the incremental analysis. So 3 versus 1. 3 versus 1, we have already done it. I will not repeat the work. 3 versus 1 gave us the conclusion that alternative 1 wins. So I will say alternative 1 wins. So I will eliminate 3. The next thing that we have to do is 2 versus 1. 2 versus 1, if you want to, I have not done this before. 2 versus 1, look at here, I don't have 2 versus 1. 2 versus 1 is negative 51 minus 28 and negative 12 minus 20. So I will have these 5 years and it will be 8 here and 23 here. Again, calculate the present worth as a function of I, set it equal to 0 to determine the rate of return. So negative 23 plus 8 times P given A, I% and 5, and I will set it equal to 0. Following the same approach that we had before, back over different tables, it seems that this answer will be something between 20 and 22%, which is less than MAR, minimum attractive rate of return of 25%. Based on that algorithm that we have, we conclude that 1 wins in this round. So therefore, I will eliminate alternative 2 and 1 will be selected. So I come to the conclusion that alternative 1 is the second best alternative. So again, be careful. If you want, let's say you selected the first best alternative and it was alternative 4. If I ask you to determine the next best alternative, don't just say, okay, so the last comparison was between 4 and 2. So if 4 is the best, then the next best alternative will be 2. No, that approach is not correct. You need to go back to your list from the scratch, eliminate the first best scenario, and rerun the incremental analysis for the remaining one. For the remaining alternatives, I have 1, 3, 2, and I redid all these analysis from the scratch to determine the next best alternative. So I will pause this video here.